Yeah, we'll start off by finding the inverse of this function. So I'm going to replace that f of x with a y. So I have y equals x squared plus 1. And now I need to interchange x and y in order to find the inverse. And then we want to get y by itself. So we're going to subtract 1 from both sides. Now we have y squared. So to get that y by itself, I would need to take the square root of both sides. I'm going to go ahead and flip this around so I have my y here on the left. Anytime we take the square root of both sides, we'd have to use the plus or minus. So we get plus or minus square root of x minus 1. Now at this point, we can't really have both of those options. If I use both positive square root of x minus 1 and negative square root of x minus 1, I'm going to end up with something that's not a function. So I need to pick one, but I can't just choose randomly or choose what I think is most convenient. I have to go back and look at this condition up here that was given. Says our function f of x equals x squared plus 1. We're only using that, and it's only valid for values of x that are greater than or equal to 0. In other words, x is positive or 0. So in our evaluation of the inverse, we interchanged x and y. So if originally x was positive, and we interchange x and y, now we're saying that the y is positive. So here we are going to go ahead and choose the positive square root. So our inverse function is the positive square root of x minus 1. And now let's go ahead and graph our function and our inverse function. So our original function f is x squared plus 1. That x squared function, that's one of our common functions that generates that U-shaped parabola. The plus 1 is just going to move that up 1 unit. So our vertex is now at 0, 1. But we have to keep in mind this other condition here, that we're only using values of x that are greater than or equal to 0. So I could go ahead and plug a 1 in for x, I'd get 1 squared plus 1, that's 2. I could plug a 2 in for x, I'd get 5. And so on. So don't sketch any part of this graph off to the left, because those would all involve values of x that are less than 0. And we're only graphing this function for values of x that are greater than or equal to 0. Now to get a graph of f inverse, even without knowing the equation, I can generate a graph here simply by taking these ordered pairs that we plotted for f and interchanging their coordinates. But because we have the equation, let's go ahead and use it. So this is a square root function that's shifted to the right one. So our endpoint of our square root function is at 1, 0. And we can just go ahead and plug some other values in if we want. So if I plug a 2 in for x, that gives me the square root of 1, which is 1. If I plug a 5 in for x, I'd get the square root of 4, which is 2. And so on. And so we could do a kind of a quick double check here and make sure that our ordered pairs are just switched around. And so here on our graph of f, we have the point 0, 1. On f inverse, we have 1, 0. On the graph of f, we have 1, 2. On f inverse, we have 2, 1. On the graph of f, we have 2, 5. And on f inverse, we have 5, 2. And so those are indeed the graphs of functions that are inverses of each other.